Welcome back. Now that we've explored Power Query's data transformations for numerical and text data, it's time to finish our coverage of the big three data types by diving into date data. So date and time transformations in Power Query are most commonly used to extract components from a date. For example, the day of the week, the month, the year, etc. Pretty simple stuff, really. For example, we can quickly add a new column to our dataset that lists the name of the day of the week alongside each sale date. So we've already got our sale date column selected, and we know we want to add a new column, so we've got our Add Column tab selected. So now we'll look in the From Date and Time section of that tab, and then click the Date button. And here we see a lot of options for how we can parse individual components out from a date. So the component we have in mind is the name of the day of the week, so we'll roll down to Day and hover over that, and we see that the last option is Name of Day. So we'll select that, and then if we scroll over to the right, we see we now have the name of each day in our sale date column. Now this is the kind of transformation that, were you to try to accomplish it with conventional Excel, would require a formula or function. Whereas with Power Query, you're able to accomplish it with just a few mouse clicks. Now that in and of itself is cool enough, but a more interesting application of date transformations is building what's known as a calendar table. A calendar table contains a series of sequential dates, typically encompassing some time period of interest, with one row per date. Now on its own, a list of dates isn't terribly interesting. But where calendar tables contribute their value is with additional columns that feature either components of the dates, like month or year, or information about them. For example, whether a particular date is considered a holiday or not. Having all this information in one place gives us a one-stop shop for everything we might want to know about a particular date. And instead of having to rederive all of this information in 100 separate places, as is so often the case, we can get it for free just by linking to our calendar table. Now, as an aside, we'll talk a lot more about connecting different tables, as well as interesting applications of calendar tables in particular, later in the course. So to create our calendar table, first we need a list of dates. Now, it is possible to generate such a list using the M programming language, which we have actually been writing this entire time without even knowing it. If you look up at the bar directly above our data preview, which looks very much like the formula bar in standard Excel, you see some very strange looking code that corresponds with the latest transformation step we applied. That's the M programming language, and Power Query has been writing it for us every time we apply a data transformation. But the thing is, learning M is a challenging and time-consuming enterprise on its own, and 99% of what you'd ever need to do in Power Query, you can accomplish with graphical tools like we've been doing so far. So for now, we'll stick with the easy way, because I want you to be able to easily remember how to do this. Now for our purposes, we're going to source that list of dates from a list in an Excel file, which you can see here. Now I was able to generate this very quickly just using Excel's autofill feature. Also note that the dates are formatted as a table, which is Excel's built-in feature for dealing with structured database type data. Now, Power Query is smart enough to recognize ranges of data in Excel sheets even if you don't format them as tables most of the time, but it's still a best practice to format any data in an Excel worksheet that you intend to pull into Power Query as a table. So back to our Power Query editor. Now we're going to import that table into Power Query. Now, thus far, we've only been working with one external data source at a time, and we can see that external data source over on the left side of our screen under the Queries heading. But you can actually work with multiple different data sources in a single Power Query editor, as we're about to see. So if we want to pull in a brand new external data source and form a brand new query or connection, first we'll go to the Home tab, and then over on the right, in the New Query section, we'll click New Source. And then because we're pulling our data in from a file, we'll hover over File, and then Excel Workbook. And then it's just a matter of navigating to our Excel file, and then selecting it and choosing Import. And Power Query is now automatically detecting all the objects in that workbook available for import. Now we formatted our dates as a table, so we'll choose Table 1. And if we look at our preview, we see that it looks like exactly what we want to pull into Power Query, just a list of dates. So we'll click OK. And now our new connection, our new external data source, is selected by default. So we have different data in our data preview section, and we also have a different set of applied steps over on our query settings pane. Now, first of all, I don't really like that name of our data connection, Table 1, so I'm going to rename it Dates. And now that we have our list of dates in Power Query, I want to scroll to the bottom of that list just to call out one additional aspect of building calendar tables. So where I am right now, it is August of 2021. But if we roll down to the bottom of our table, we see that I have dates going all the way out to the end of 2021. It's actually very common for calendar tables to do this because we don't want to have to update our source file constantly. We don't want to have to add a new date to that file every day and then re-import it. So there's really no harm in just extending that list of dates far out into the future, so we only have to do very, very periodic updates to our data source. So now that we have our list of dates in place, it's really just a matter of adding columns that parse out information from each of those dates. So I'll start by adding the name of the weekday, just like we did in our home sale dataset. So I'll go to the Add Column tab, and then hit the Date button, and then go down to Day, and then choose Name of Day. And next I'll add the week of the year. So again, Date button, and now I'll hover over Week, and then choose Week of Year. And while I could change these column names, I actually am okay with the column names that Power Query is choosing by default. So next, I'll parse out the name of the month for each date in our Dates column. So again, I'll hit the Date button, then I'll hover over Month, and then I'll choose Name of Month. And then I can do Quarter, and I can also do Year. And one more interesting piece of information you can parse out of a date using Power Query very easily that's somewhat more difficult to get to with conventional Excel is the first or last day of the month associated with a given date. So if I go back to our Dates column and select it, and then hit our Date button again, and then roll back over Month, I can either parse out the start of the month or the end of the month. So I'll choose Start of Month. And now we have a column containing the first day of the month for each of the dates in our calendar table. Now obviously I could keep adding more and more derived columns like this for days, pardon the pun, but I think you probably get the point. The idea here is that we will have, for each date in our calendar table, all the attributes of that date that people might be interested in, so that instead of people having to rederive those attributes with formulas and functions, they can just tie right into our calendar table and get them with almost no effort. All right, up next, we're going to switch gears a little bit and take a look at how you can apply conditional if-then type logic to your data transformations. I'll see you then.